In this video, we will discuss how to solve square root equations and cube root equations. So let's go ahead and look at our first equation. It's a radical, but to be more precise, it's a square root because the index is a 2. Now, if you're asked to solve an equation, it means you have to find x. You have to find the solution. So let's copy our first equation down. And to get x, which is under the radical, you have to first of all isolate the radical by dividing both sides by 2. You need to get rid of the 2. Now once you divide both sides by 2, you get square root of x plus 1 equals 7, because 14 divided by 2 is a 7. Now let's copy this to our second column. Now to get to the x inside the radical, you have to get rid of the radical. Now since this is a square root, because the index is a 2, it means I have to square both sides to get rid of the square root. If this is a cubic root, then you have to cube both sides to get rid of the radical. So you have to apply the inverse operation. Now by squaring this square root, the radical, it cancels out and you end up having x plus 1. You see how you're getting to the x? Now on the other side, 7 to the power 2 is a 49. Because 7 times 7 is a 49. Now let's move this to our third column and let's solve for x. To solve for x, you need to isolate it. So you need to move the 1 to the other side by subtracting it. So x equals 49 minus 1, which is a 48. Now you cannot just box it and call it a day. You have to check if this actually works. How do you do that? You need to plug it back into the main equation. So let's take a closer look at the main equation. So I would copy it correctly. I would hate to do the whole work and then go back to figure out that I did not copy the right equation. So let's go ahead and plug in 48 for x, and let's check if this is actually going to give me a 14. Now, 48 plus 1 is a 49. 2 times, what's the square root of 49? It's a 7. So 2 times 7 is a 14. That did give me 14. So yes, x equals 48 is a solution. Now remember, you have access to the calculator, so you can put this whole thing into your calculator, into your main screen, 2 square root of 48 plus 1. If you get 14, then you know that it's correct. Now let's move on to our next equation. Now, as you can see, the radical is isolated, so my first step is done. Now remember, to get rid of the radical, in this case this square root, you need to square both sides. Did I copy this correctly? Yes. Okay. Now when you square both sides, you have to remember you have to square all of x minus 2. Now a common mistake that students do is that they square the x and they get x squared, and then they square the 2 and get a 4. But that is incorrect. You have to square all of x minus 2, which means you have to write x minus 2 twice, and you have to actually FOIL it. So x times x is x squared. X times negative 2 is a negative 2x. Negative 2 times x is a negative 2x. And negative 2 times negative 2 is a positive 4. Okay? Now go ahead and combine like terms. So you get negative 4x, since negative 2x and negative 2x is a negative 4x plus 4. So this is how you would go on by doing x minus 2 to the power 2. Write it twice, FOIL it, combine like terms. Now, let's take a closer look at the left side. Since I am squaring the square root, they cancel each other. So I end up having x plus 18 on the left side, and this is what I have right now after I square rooted both sides, after I squared both sides. Now to solve, since you have an x and x to the power 2, you need to move everything to one side of the equation. How do you do that? You do that by subtracting x from both sides. So you get 18 equals x to the power 2. Now negative 4x and minus x, that's negative 5x plus 4. Now again, you have to subtract 18 from both sides. So you end up having a 0 equals x squared minus 5x. Now 4 minus 18, that's negative 14. There you go. Now to solve this, since it's a quadratic equation, you need to factor. So I want you to look at the a, which is a 1 in this case, and the c, which is a negative 14. And I want you to think of two numbers that when you multiply, you get ac, which is in this case negative 14, and add to give you b, which is in this case negative 5. So what multiplies to give me negative 14 and add to give me negative 5? Now, if you're having trouble finding those two numbers, remember at any time you can go to y equals on your calculator, put negative 14 over x, and then go to the table and look on the x and the y value on the table on the calculator for the two numbers that would add to give me negative 5. And you will see that those two numbers are negative 7 and 2. So once you find those two numbers, this is a good review of factoring. Once you find the two numbers, which are negative 7 and 2, then you will know that your first factor is x minus 7 and your second factor is x plus 2. Now the solution, you need to set each factor equal to 0 and you need to solve for x. So my first solution is x equals 7. Now let's put the second factor equal to 0 and let's solve for x. So my second solution is x equals negative 2. So I have two distinct solutions, x equals 7 and x equals negative 2. Now they might both be acceptable solutions, or maybe one of them is acceptable and the other is extraneous. Now to do that, I have to plug it back into the equation and see if both works or not. But before we do that, let's review what we did. Now we have to isolate the radical. It's isolated, there's nothing being multiplied or added, so then it's in perfect shape to continue solving. To apply the inverse operation, to me, since this is a square root, you need to square both sides. So once you square root of x plus 18, they cancel each other and you get x plus 18. Now when you square x minus 2, it means you have to write it twice and FOIL. Remember to combine like terms. Once you do that, remember since you have a square and x's lying around, you can't just move all the x's to one side and all the numbers to the other like we usually do. No, you have to move everything to one side of the equation and you have to set it equal to 0 because most likely you will need to factor. You use big X or any method that you like to factor. You find the two numbers that multiply to give you AC, which is in this case 1 times negative 14, and add to give you B. Once you find those two numbers, these are your two factors. You set each factor equal to 0 to find the x values. Okay? Now, let's go ahead and check if x equals 7 is actually a solution. So let me go back. Square root of x plus 18 equals x minus 2. So let me write that down. And let's plug in 7 for x, and let's see if this is going to work. Now again, you can plug all of this in your calculator. You can plug in square root of 7 plus 18, all of it in your calculator, and you will see that 18 plus 7 is a 25, and square root of 25 is a 5. Now 7 minus 2 is a 5. So yes, they are equal to each other. So x equals 7 is a solution. It's an acceptable solution. Now let's try x minus 2. Let me copy down the equation. Now let's plug in negative 2 for x. Now you can put square root of negative 2 plus 18 in the calculator, or you can just solve it by hand. Negative 2 plus 18 is a 16. Square root of 16 is a 4. And negative 2 minus 2 is a negative 4. Now 4 and negative 4 are not equal to each other, so x equals negative 2 is not an acceptable solution. We call it an extraneous solution. Extraneous solution means we solved and we got x equals negative 2 as one of the solutions, but when you plugged it back into the equation, it didn't work. So that's why it's called extraneous solution. So the only acceptable solution is x equals 7. Now let's move on to our third example. which is solving half-power equations. Now the half power is basically just the rational exponent, but you can change it into a radical expression if you feel more comfortable doing that, and this is what we will do. So let's copy the equation down into our first column. Now to be able to solve this one, I have to isolate the radical, and the radical is basically, since I have the bottom of this fraction to be a 2, then the index of this radical is a 2, and then 2m minus 6 goes inside the radical, and the 1 on top of the fraction is going to be your power. Since it's just a power of 1, I don't have to write it down. Now negative 16, I have to add 16 to both sides. So I end up having equals 16, and there you go. I isolated the radical. Now change then the rational exponent into a radical expression. Move the negative 16 to the other side of the equation. Now, I have a square root of 2m minus 6 equals 16. Now remember, you do not have to write the square root. You don't have to write the index 2 for the square root. So 2m minus 6 equals 16. To get rid of the radical, I have to square both sides. So I get 2m minus 6, since when you square a radical, the square root just goes away. They cancel each other. Now 16 to the power 2 is 256. Now to solve for m, let's move on to our third column. To solve for m, I have to add 6 to both sides. So 2m equals 262. And now to get m, I have to divide both sides by 2. So m is equal 131. Now remember, I have to always plug it back in because most likely it will work in this case, but sometimes it might not work, so I always have to check my solution. So let me move backward. 2m minus 6 to the power half. So 2m minus 6 to the power half minus 16 equals to 0. Now plug in 131 for m. Now again, you can do all of this on the calculator to check. So 2 times 131, that's going to be 262 minus 6 to the power half. Again, you can put this in the calculator and do the work. 262 minus 6, that's going to be 256. So basically, I'm just working myself backwards. Now, if you try to put 256 to the power, so see, you hear the calculator, 1 divided by 2, that's a 16. Minus 16 equals to 0. So I can do that on the calculator. Now, since I got to the 0, it means yes, m equals 131 is an acceptable solution. And this is how you would solve a half-power equation. You just change it to a radical because maybe you're more comfortable working with a radical. Okay? And even you can do that when you check. You can just change it into a radical, or just plug in 131 for m and do the whole work on the calculator, and you will get a 0. Now let's move on to our... And in our next example, we'll be solving cubic root equations or cube root equations. So let's go ahead and move our first equation to our first column. So 5 cubic root of x plus 2 and minus 20 is outside the radical. This is equal to 0. Now to solve for x, I need to get the x by itself. So I need to isolate the radical first. I do that by moving the 20 and then dividing by the 5. So let's add 20 to both sides. So I get 5 cubic root of x plus 2 equals 20. Now to get the radical by itself, I need to divide both sides by 5. So I get cubic root of x plus 2 equals 4. I isolated the radical. Now let's transfer this equation to our next column. And remember what we talked about before? If I want to do the inverse operation to get rid of the radical, since this is a cube root, I have to cube both sides to be able to get rid of the radical, because the cube and the cube root will cancel each other. I will be left with x plus 2 on the left side, and I need to cube 4. So put 4 to the power 3, that's a 64. Now to get x, I need to subtract 2 from both sides. And then x will end up being 64 minus 2, which is a 62. Now remember, you always need to go back and check. So let's copy our equation. Oh, I should have done all of this work in this column. Excuse me for that. Now let's go ahead and copy the equation into the last column to check our work. Now 5 cubic root of, and plug in 62 for x. Now again, you can do all of this work on the calculator. Now to get to the cube root on the calculator, you click on math. So let's do that. So click on math, and then you go all the way down to number 4. Number 4 looks like this. Okay? Cube root. So you can actually do it on the calculator. Or let's do it by hand. 5 cubic root of 62 plus 2 is a 64. Now cube root of 64, it means think of a number that multiplied by itself 3 times to give you 64. So 4 times 4 times 4 is a 64. So the answer is a 4. Now 5 times 4 is a 20. Minus 20, that's a 0. So that is correct. So the solution x equals 62 is an acceptable solution. Okay? But again, you can put all of this in your calculator and see if it will give you a 0. Now let's move on to our next example. As you can see, it's a rational exponent, but no worries, you can change that into a radical expression. Let me zoom in so I will have more space to write. Now let's go ahead and get rid of the 2 since it's outside the parentheses, so let's move it to the other side. X minus 50 to the power 1/3 equals negative 10 divided by 2, that's a negative 5. Now let's change this rational exponent to a radical. So let's put a radical. On the bottom of this fraction I have a 3, so the index of this radical is a 3. I put x minus 50 inside the radical, and it's to the power 1 since the top of the fraction is a 1. And that's equal negative 5. Now let's transfer this equation to our next column. Now remember, to get rid of the radical, you have to do the inverse operation. Since this is a cube root, so I cube both sides, okay? Now when you cube a cube root, they cancel each other. I'm left with x minus 50. Now negative 5 inside the parentheses, so do that on your calculator. Negative 5 to the power 3. So you hear that? I'm doing everything on the calculator, and you can do that too, equals 125. Now to solve for x, I need to move the negative 50 to the other side by adding it. So x is equal negative 125 plus 50, that's a negative 75. Now once I get x equals negative 75, I need to double check that I'm doing the correct work. I did the whole work in this column again. I need to pay more attention. Okay, now let's move the whole equation into my last column, because I need to check if negative 75 is an acceptable solution. So put x as a negative 75, negative 50, all of this to a 1/3, and we're going to check if this is going to give me negative 10. So what I'm going to do is I'm going to go to my calculator. I'm going to put this on my calculator. So 2 parentheses, negative 75 minus 50, close parentheses, to the power. You can do alpha y equals to create a fraction. And then put 1 on top of the fraction and 3 on the bottom of the fraction. Now press enter, and yes, I got a negative 10. So it means negative 75 is an acceptable solution. It's not an extraneous solution. Okay? Now let's move on to our last example. Now, yes, I see that it's a fraction 1/5, but no worries. We can change it into a radical. The bottom of the fraction will be my index. And then 3x minus 1 will be on the inside. Since the top of the fraction is 1, it means this is all to the power 1, which is not going to change. So I just change that into a radical expression. Now, let's transfer this to our next column. And remember what we said before? To do the inverse operation to get rid of the radical, let's look at the index. What's the index? It's 5. So I need to raise both sides to the power 5 to get rid of this radical, because if it's a fifth root, if I raise it to the fifth power, they cancel each other. So I get 3x minus 1 on the left side and 2 to the power 5. Let's do that on the calculator. 2 to the power 5. That's a 32. Okay? So you see that? It doesn't matter. Even if it's 1 over 6, it means the index is 6. If this is 6, then I have to raise it to the 6th power, and I do that to both sides. To find that, you just put it on the calculator. Now to solve for x, I need to add 1 to both sides. Okay, I'm glad I remembered. Now I'm going to move it to the third column, and I'm going to solve in the third column. Now add 1 to both sides. You get 3x equals 32 plus 1, which is a 33. You divide both sides by 3, so x equals 11. Now, let's put it back into the equation and check if this is acceptable. So I'm going to write the whole equation down. Instead of x, I'm going to put times 11, because 3x means 3 times x. X is 11, so 3 times 11 minus 1 to the power 1/5. 3 times 11 is a 33 minus 1 to the power 1/5. So I'm going to go to my calculator, open parentheses, 33 minus 1, close parentheses, to the power, I can put 1 over 5, and it gave me 2. So yes, it is equal to 2. So yes, x equals 11 is an acceptable solution. This is how you solve if it's this type of radical. It doesn't matter what the index is. You always use that, and you raise both sides of the equation to that power. Now I hope this video was helpful. Remember to do the practice sheet to practice and be better at solving radicals or radical equations.